Yo, 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 yo. Yo, 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 yo. Yo. Hey, everybody. Here we go. We're going to make predictions with experimental probability. You have no key terms. Which is nice because some of you never actually write down the key terms, so you don't get credit for your notes. So this is like your luckiest day ever. You must be really happy about that. So no key terms or anything, but we're going to talk about how to make a prediction once we figure out the experimental probability of something. So let's get to some examples. So Danae found that the experimental probability of her making a bullseye when throwing darts is 2 every 10 throws, or 20%. That's actually pretty good, I would think. So 20% of the time, 20% of the time when she throws a dart, she is going to hit the bullseye. So 2 out of every 10 throws, she's going to hit the bullseye. Out of 75 throws, about how many bullseyes could she predict she would make? So there are 2 ways to do this. We could set this up as a fraction and set it up, well, we know 20% is 2 out of 10, and that's equal to x over 75. We've done a bunch of these. Okay, I could do it this way because I'm trying to figure out how many out of 75 when I know it's 2 out of 10. That's one way to set it up and work it out. I would do my cross products. That's 10x. 2 times 75. That's 150. Equals 10x divided by 10. I get x equals 15. So we can predict 15 times. That is one way to do this. And that's the way that we've done a lot this year. However, I'm going to show you probably a way that I think you're going to like a little bit more than that. So we know that the prediction is 15. So we're making predictions. I can always set it up where my ratio of how many she gets bullseye equal to x over 75 to predict. That's how we've been making predictions with a lot of stuff all school year. So another way I can do it, I know by experimental probability she gets it 20% of the time. Well, that means 20% of her throws hit a bullseye. I need to just know then what's 20% of 75. That's really all I'm trying to figure out. Because if she's doing a total of 75 throws, 20% of that by experimental probability would tell me, well, how many times she's going to hit the bullseye. Well, now I can convert 20% into a decimal. So 20% to a decimal, I move my decimal over twice, is just 0.2. So 20% of 75 is 0.2 times 75. And then I just multiply those two values. 0.2 times 75 is 15. I'm done. So you can just convert your percentage into a decimal and then multiply that by the total number of throws. I'm really just figuring out, okay, well, if I hit it 20% of the time, what's 20% of 75? If I throw 75 times, I should hit it 20% of the time. So I need to multiply 20% by 75. And that's your final answer. So 2 ways to do it. You can do the cross products, like what we've done in the past, or you can just multiply your percentage by your total amount of throws, or your total amount. Try this one on your own. Just try it. See how you do. A car rental company sells accident insurance to 24% of its customers. Out of 550 customers, about how many customers are predicted to purchase the insurance? So let's say they get 550 customers in a week. They want to know how many customers are going to purchase the insurance. Well, 24% of the time it happens. So I need to figure out what is 24% of 550. Okay. So, well, 24% is 0.24 because I moved my decimal over twice. So it's 0.24 times 550. This is where it's really nice to have a calculator. Let me pull one up for you guys right now. Math Tools calculator. Beautiful. There it is. So if I have 0.24 times 550, 132. That means we can predict that out of the 550 customers, 132 of them will buy the insurance. And that's it. I just change my percentage into a decimal, and then I multiply it by the total, so then I can make my prediction. Okay. A doctor's office records data. A doctor's office records data and concludes that on average 11% of patients call to reschedule their appointments per week. Let's see, there's a total of 240 total appointments. The office manager predicts that 23 appointments will be rescheduled out of 240 total appointments during the next week. Explain whether the prediction is reasonable. So prediction has already been made. They predicted 23 out of the 24 would be rescheduled. Out of the 240 would be rescheduled. Well, we know that 11%, on average, 11% reschedule. So let's figure out what 11% of 240 is, because that should be the prediction. So if I want to know 11% of 240, because that's how I would figure out, if I didn't have this prediction alone, I would do this on my own. I would figure out, well, what's 11% of 240? So that's 0.11 times 240. Again, let's use that sweet calculator. 240 times 0.11, 26.4. So that would be our prediction. Our prediction would have been 26 patients. Now we have to answer the question, though. The question is this a reasonable prediction? I think it is. 23 to 26 is pretty close when we're talking about a total of 240. So I think it's definitely a reasonable prediction. It's pretty close to the 11%. This is more about 9%. Okay. But it is really close. So, but depending on your explanation, I think you can make the argument for both. If you said, no, it's not reasonable because 11% of 240 is 26, then that would be a great explanation as to why this is not a reasonable. But if you said, 23 appointments is reasonable because it's 11% of 240 is 26 and 23 is relatively close, I think that would be a great explanation as to why it is a reasonable prediction. But really, I would actually, now that I think about it, I would say it's probably more unreasonable just because it's simple math to figure out the prediction. The reasonable prediction would be 26 because 11% of 240 is 26. But this is where explanations matter and your words matter. Okay? All right, finally, try this one, see how you do, and then this will be our last one. An online poll for a movie site shows its polling results for a new movie. So this new movie, 72% of the people liked it, 28% of the people didn't. If a newspaper surveys 150 people leaving the movie, how many people can it predict will like the movie based on the online poll? Is a movie site's claim accurate if the newspaper has 104 people say that they like the movie? So again, we're trying to figure out if a newspaper surveys 150 people leaving the movie, how many people can it predict will like the movie based on this poll? So we know 72% like it. So I need to know what's 150 times 72%, which is also just 0.72. So that's what I'm doing. I'm doing 150 times 0.72. 108. So that means based on this poll, 108 people out of 150 should like the movie if we're using these results. Is the movie site's claim accurate if the newspaper has 104 people say they like the movie? Again, this is where your explanation comes into it because that's pretty close. They're off by 4, but when they're saying 108 instead of 104 out of 108, I think that is definitely reasonable. And it's definitely accurate. Okay. That's it, guys. So, things to remember. Move decimal in percentage 2 times left. And then show an example of that. So if I have 65%, that's really 0.65. Then we can multiply. So don't multiply the percentage. Always move it over twice to the left, which would be your 1, 2. And there you go. All right, there's your independent practice. Try it out. See how you do. If you have any questions, please let me know. Thank you for tuning in. Gradius out.